Mole ratios are just the numbers that are in front of our compounds in a balanced chemical equations. Most students know that, but still mess up when units and compounds change mid-problem. In this video, I'll show you how to pull mole ratios from balanced equations and use them to solve real problems. So if we look at our first example, if we're given this balanced equation, 2H2 plus O2 yields 2H2O, if we start with 4 moles of H2, how many moles of H2O will form? So if we look at our balanced chemical equation, 2 moles of H2 will give us 2 moles of H2O. We can form a ratio with this. So we can say for every 2 moles of H2, we get 2 moles of H2O. A 2-to-2 ratio or a 1-to-1 ratio if we simplify it. So now all we're going to do is write this conversion and cancel out our terms so that we end up with moles of H2O. So we're starting with 4 moles of H2. We're going to multiply by this ratio that we just found from our balanced equation, 2 moles of H2O over 2 moles of H2. Now the reason I put H2 on the bottom and H2O on the top is because in our first term, we have moles of H2 on the top. We want to cancel that unit out so that our unit ends up being only moles of H2O. So now we just solve algebraically. 4 times 2 over 2, which is our ratio, gives us 4 moles of H2O. We also know this is correct because if we refer back to our ratio, if we have 2 moles of H2, we get 2 moles of H2O. They're the exact same. So that means if we have 4 moles of H2, naturally we'll have 4 moles of H2O. Let's look at another example. If we are given 5 moles of H2, how many moles of NH3 will we have? Well, we want to look at our ratios. So we want to make sure that our equation is going to be a balanced chemical equation. If not, our ratios will be wrong because we won't have the right coefficients. So I see on the left side, I have 2 nitrogen. On the right, I only have 1. I can fix this by putting a coefficient of 2 in front of NH3. And then to balance my hydrogen, I can put a 3 in front of H2. Now my equation is balanced and I can look at the ratios. So if I'm starting with H2, I can see that 3 moles of H2 gives me 2 moles of NH3. It's a 3-to-2 ratio. So let's set up this conversion. We're starting with 5 moles of H2, and I'm just going to multiply it by our ratio. So I'm going to have 3 moles of H2 on the bottom and 2 moles of NH3 on the top. So my moles cancel out. And when I solve algebraically, I end up with 3.33 moles of NH3. Where most students mess up is they try to use the subscripts from the chemical formula instead of the coefficients from the balanced equation. The subscripts tell you the number of atoms in one molecule, but mole ratios only come from the coefficients. So many times you may see people putting a 2 for the nitrogen, a 2 for the hydrogen, and a 3 or perhaps a 4 for the NH3. But again, like we saw in the last 2 examples, these aren't mole ratios. The ratios of our molecules between each other come from their coefficients. So it would be 1 here, the 3 here, and the 2 on the right side. Let's look at a multi-step problem. It asks us how many moles of CO2 come from 88 grams of oxygen gas. So we're given a combustion equation here in the green. And we want to do the exact same thing, except we have to add one more conversion. Instead of starting out with moles like we've seen in the last few problems, we're starting with grams. So we need to convert from grams to moles using our molar mass conversion factor. So our first step is to convert grams of O2 to moles of O2. So we have 88 grams of O2, and we're going to multiply this by our molar mass, so 1 mole of O2 over 32 grams of O2, which turns to 2.75 moles of O2. This is the first step in our mole to mole ratio. We need to figure out how many moles 88 grams is, and then we can apply our mole to mole ratio here. So the next step is to apply the mole to mole ratio. We're going to have our 2.75 moles of O2, and we're going to multiply this by, well, it's a 5 to 3 ratio. So I'm going to put my 5 moles of O2 on the bottom so that it cancels out with the top in the previous term, and my 3 moles of CO2 on the top. These units cancel out, and when I solve algebraically, I end up with 1.65 moles of CO2. For more detailed stoichiometry examples, including more multi-step mass problems, you can check out the complete stoichiometry breakdown, and I'll link it below. If this helped, subscribe for more tutorials.